Hello, so we are gonna do a few questions about the natural log application. So we have like number of bacteria, like as given P of H in a certain population increasing according to the given this function when we have H as to be the hours. So how many hours will it take for the number of bacteria will be 3,300. So let's make sure we understand the numbers. Like basically it's telling us the P of H is gonna tell us the number of bacteria, okay? And then H is gonna be number of hours after whatever we start in terms of timing. So that's why we're gonna need to find the H when we hit this number. So for P of H. So let's go ahead and try writing this equation first. So 3,300 is gonna be our goal to achieve. So you get 2,700 times e to the 0.08 h. So, we want to find the h alone, but that's the exponent. So when we are trying to find the exponent, that's the job for the logarithm. But before we do, we kind of need to remove this coefficient from this exponential part. So maybe I can simplify, divide both sides by 100 to cancel these zeros to make it a bit simpler. So I can now divide by 27. Maybe I can divide by 3 in my head. That's going to be 11 and 9. So just divide by 3. So you will get 11 over 9 is equal to e to the 0.08h. So now this is the exponential like form. So when we try to convert into this logarithmic form, so we can just remember that could be written like log, and then the base of the exponential form is e. So we are going to use that base e, and then e to the this power has to be our result. So in the logarithmic form, so we are just converted basically. So that should be 11 over 9 is my argument. So that should be equal to 0.08h. So if you're confused with this, like this is what we had. Like if I have, let's say, y equals x to the, let's say, t in exponential form. So this was equal to log. So that this base x will be base of the log. And then the power t, which is a variable I like to get alone. So will be here. I mean, not x to the t will be here. So actually it wasn't the case. So that will be like x to the, like we just say, that's going to be y is equal to t. So the short way to remember was we take this x and then take this exponent, and then that was equal to this guy. So the base is x, which is this number. X to the whatever the result has to be our argument. So in the logarithmic form, so that's what I just did right here. So, but we know we don't want to use log when we have the base is e, so which we use natural log. So which is why instead of writing log e, we can write natural log of 11 over 9. That is my entire argument, is equal to 0.08 h. So like you can now plug this into a calculator and divide both sides by 0.08. So that will give us h. So because that's what we are interested. So let's divide by 0.8. So these will cancel, and then I'm gonna get the h alone. So now we can just plug this into calculator. So if I try that, so we want to be careful. We have a 11 over 9 as argument. So natural log is this one, and then argument is the fraction. So I'll just go ahead and hit 11 over 9. In most calculator, like when you use this order like 11 and division, so you may not be typing as a fraction, so be aware of your calculator that you use. So that would be the numerator. So we are going to divide this by 0.08, right? And then when you do this, I should be getting the hours, which is 2.5. So it says the nearest 10, so 2.5 looks good. So like the key takeaway from this problem is basically just writing the equation with the given like numbers, and then as soon as you realize that's the equation as like e as the base and the exponent is what you are interested, so you want to make sure you convert into a logarithmic form, which is I can do it this way, and that is the natural log notation, and that is basically what we did, and then the rest just plug into calculator. So that was the answer. Let's go ahead and check that. Yep, that was correct. Okay, so here's the second problem of the same kind. So we have Kira place a bottle of water inside a cooler, and as the water cools, the temperatures are changing by this given formula. And she wants to drink the water when it reaches a temperature of 14 degrees Celsius. And how many minutes should she leave it in the cooler? So like, the 14 degrees is her like optimal like degree, has to be that C of T. So then we want to find what that T should be in terms of timing to get that 14 degrees. So we are going to use the same logic as the previous problem. So the 14 is given as our C of t, and then this is equal to 6 plus 14 times e to the negative 0.034 t. So like we want to get the t alone as well, but there are like some other stuff going on inside in front of the e. So maybe I should remove this 6 first, because I cannot just convert this exponential form, in logarithmic form again. So I'll subtract 6 from both sides. So if I subtract 6 from both sides, so you'll get 8 equals like 14 times e to the negative 0.034 t. And now we can maybe remove this 14 by dividing both sides by 14. If I divide both sides by 14, you get 4 over 7. If I simplify, 8 over 14. So that will be equal to e to the negative 0.034t. Okay, so now we have this. let's just convert it into exponential form. So this could be written like, our base is 8, so I can use natural log. Natural log of the 4 over 7. 4 over 7 will be my argument, is equal to the power, so which is negative 0.034t. And if I want finding like t, so I can divide by that coefficient. So the t should be like natural log of 4 over 7. So this is 7. Divide by this negative 0.034. Okay, so if I plug this into a calculator, I should be getting my answer. So let's see. So we have natural log, so which is 4 over 7. Okay, and then I'll say this will be divided by a negative number, 0.034. Like, think about this. We are looking for the number of minutes, but the number is negative number. So if your numerator is like positive, then the result doesn't make sense because negative divided by negative is negative. So the number of times shouldn't be. So meaning that the numerator should be a negative number. So natural log of 47 should be a negative number. You can kind of ask yourself, is it really a negative number? Like without really putting into a calculator and kind of make it like reasonable, like explanation for that, but that is actually a negative number. So when you divide by negative, so you get just 16 as a positive. So we are looking for how many minutes, which is nearest 10. So 16.5 should be the time should take for her to wait. Okay. So anyway, so that was the second question, just applying the natural log into different setting. So I hope that was clear. I'll see you in the next video.